So let's solve a few problems based on application of Varignon theorem. So a parallel force system is given as per figure. Okay, so we can see here 5 forces are acting on this body or on this system or on this bar, and the perpendicular distance or distance between two forces are given. Now we have to find the resultant. What is the resultant force of this parallel force system, as well as the position of resultant from the point A. Okay, so now we will follow the steps as I discuss. So first is find the resultant of parallel force system. So resultant is nothing but the algebraic sum of all the forces Fi and R equal to. So now I am using this direction as a positive and this direction negative. Okay, so I will use this sign convention while doing the algebraic sum of these forces. So 200 is in downward direction. Okay, so minus 200, 500 is in plus direction, 350 downward direction, minus 150 plus 150 and plus 200. Okay, so this is the simple algebraic sum of all the forces. So R equal to 850 minus 550 is equal to 300 Newton. Okay, so this is the value of the resultant force of this parallel force system. Now the second step is to estimate or to calculate the moments of all the forces about point A. Okay, so the moments of all the forces about A is nothing but the moments of forces, algebraic sum of moment of all the forces. So now, so moments, the force F1 means 200 Newton into 0. Okay, because we are measuring the moment. Okay, moment of this force about point A, distance is 0. The moments of 500 Newton force will be 500. Distance is 3 meter. Okay, perpendicular distance from force to point A is 3 meter, and this force has tendency to rotate the body in this direction. It means this is the anti-clockwise direction. Okay, so in this case, okay, this is only for in this case. In this case, this directions, okay, because point is here, so anti-clockwise, and tendency of these forces to rotate the body about point A is in clockwise direction. Okay, so I can write here. So this force has a tendency to rotate body in this direction. This force has the tendency to rotate the body about a anti-clockwise. This is also in anti-clockwise. So now I can write, or I can do the algebraic sum of all these moments. Okay, so now is 200 into 0 minus plus 500 into 3, and then minus force value is the 350 Newton. Distance, okay, so distance from this force, okay, perpendicular distance from this force to point A is 3 plus 4.5, okay, 7.5. Moment of this force 150 Newton. 150 is magnitude, and this perpendicular distance from this force to point A is 2.5 plus 4.5 plus 3. Okay, so plus 150 into distance is 10 meter and 200 Newton. Okay, so moment of this force is 200 multiply this distance. So now the distance is 12 meter from point A. Okay, so plus 200 into 12. So after solving this one, we can solve individual term first. 1500 plus, okay, so, and this value will be, so MA is 2775. Okay, so now we know the value of algebraic sum of all the moments of all the forces. Now the third step is, now we can apply the Varignon theorem. Okay, so MA is equal to MR. Okay, and if I assume, okay, so if I assume, so now this case is this one, so okay, so the system is this one and the point is here, this is your A point, point B, and the resultant R is positive. Okay, so R is positive means this is in this direction, R is positive, and the distance, the perpendicular distance of this force to point A is D. Okay, so then this MR is equal to R into D. So now we can solve. Okay, so R into D is equal to MA and the value of the MA is, this is the Newton meter, is 2775 Newton meter. Okay, so D is 2775 divided by 300. Okay, so this is the meter. So after calculations, the D will be around 9.25 meter. Okay, so this is the value of the D. So now you can now you can represent the system with a single force. Okay, so this is point A and this is point B, and total distance was 12 meter. Okay, so 9 is somewhere here, 9.2. okay, so this is the 9.2 and resultant R is 300 Newton, and this distance from point A is 9.25 meter. Okay, so this is the way to tackle or to solve this type of the problems by using the Varignon theorem. Okay, so now let's solve problem number 2. I read the problem. The parallel force system of 5 forces is shown in figure. Okay, so we can see here 5 parallel forces of different magnitudes are acting on this object or on a bar, and our objective is to reduce the parallel force system to a force and a couple at point P. Okay, it means we need to replace all these parallel forces to a single force, and the location of that force should be at point P. So we can use the Varignon theorem to find the position of that single force or that resultant force from point P, and then we can use the concept, then we can transfer that resultant force to point P. Okay, so find R, what is the value of resultant of this parallel force system. So resultant force is nothing but the algebraic sum of all the forces acting on this bar, and in this case we will use the positive sign here, and for this direction we will use the negative sign convention. Okay, so 12 Newton is in upward direction plus 15 in downward direction is negative, 24 in upward direction, 30 also in upward direction, and 20 in downward direction. Okay, so this is the simple algebraic sum of all these forces acting on this bar. And so if we do the sum, then the value of R will be kilonewton. Okay, so this is the value of resultant force. Now we have to find the position of this resultant force from point P. Okay, so now we have to find moments of all the forces about point P. Okay, so moments of sum of moment of all these forces about point P is MP. Okay, so now we have to estimate or find the moment of all these forces. Okay, so we have the 5 forces and we want to find and estimate the moment of all these forces about point P. So the distance from point P, or we can say the distance from the line of action of the force to point P is given. Okay, so these are nothing but the perpendicular distance from force to point P. And also in this case we have to use, now let's find the sign convention. So now point P is here. Okay, so this force has tendency to rotate the body in this direction, so 12 kilonewton, okay, in clockwise. Moment of this force will be in the clockwise direction. This force has tendency to rotate the body in this direction. Okay, so this is anti-clockwise. This force has tendency to rotate the body in this direction. This force has tendency to rotate the body in this directions about point P, and this force has tendency to rotate body in this direction about point P. Okay, so now we can use the sign convention during the algebraic sum of moments of all these forces. So moment of this force 12 kilonewtons about point P, because so now we can define here. Okay, so for the anti-clockwise plus, okay, we are using the positive value. Okay, for the anti-clockwise positive, and for the clockwise negative. Okay, so we are using this sign convention during the algebraic sum of moments of all these forces. So now we can do the algebraic sum of moments of all these forces. So moments of this force 12 kilonewton about point P is, because this is clockwise, negative, so minus 12, and distance is minus 12 into distance is 4.5. okay, and second force is 15 kilonewton. The distance from point P is, perpendicular distance from point P is 1.5, so 15 into 1.5. Sign is plus because it is anti-clockwise, 1.5. Third force is 24 kilonewton. It is also perpendicular distance between the force and point P is 1.5 meter, and this force has tendency to rotate the object in anticlockwise. Okay, so plus 24 into 1.5, and the 30 kilonewton has also tendency to rotate the body in anticlockwise direction about point P, and distance from point P 3 plus 1.5 4.5 meter. Okay, so plus 30 into 4.5, and this force 20 kilonewton has tendency to rotate the object in clockwise direction. The distance of this force from point P is 7.5 meter. Okay, so 20 minus 7.5. Okay, so now if you solve the simple mathematics, then the MP value will be around 10.5 kilonewton meter. Okay, so this is value of moment, sum of algebraic sum of all the moments of the forces about point P. Now we can use the Varignon theorem to find the position of resultant from this point P. Okay, so now let's say this is our situation now. This is point P here, and from point P, and let's say this is the resultant R, and this distance from the point, distance between point P and R is D. Okay, so this is the case. If I assume this is the case, now apply Varignon theorem here. So MR is equal to MP. Okay, and MR is nothing but the R into D, because this is the moment of resultant about point P is equal to MP. Okay, so D equal to MP divided by R, and value of MP is the 10.5 and value of R is 31. Okay, so D is approximately 0.34 meter. Okay, so this is the value of D from point P. So now we have the case. Okay, this is point A and this is point P here, and the resultant is here. Okay, because this is plus 31, so this is the 31 kilonewton here. The distance from this to this distance is 0.34 meter. Now okay, now we have to transfer this force from this position to point P. Okay, so need to transfer resultant okay, so this is 31 kN to point P. Okay, so we already discussed that we can transfer any force to a new parallel position. Okay, so we can use the concept of the force, the transfer to a new point. So we can transfer this 31 kilonewton force to point P with a force and a couple. Okay, so okay, your point is P is here, and this is our force 31 kilonewton. This distance is given here. Now if I transfer, so this is point P. Okay, so 31 kilonewton and 31 kilonewton. Okay, and this is already here, resultant is here. So this force and this force will form a couple. Okay, and magnitude of that couple will be force into distance. This is 0.34 into 0.34. okay, so value is the 10.5 kilonewton. So in this way, now we can okay, so this is point A and this is point B, and now this is point P with one force. Okay, force is here 31 kilonewton, and this couple has tendency, okay, this couple has tendency to rotate the body in this direction. Okay, so now we can here. So this is what we want to get. Okay, so now we replace all the parallel forces to a single force of 30 kilonewton at point P, and a moment or a couple of moment, the value is 10 kilonewton meter. Okay, so this is way to solve this type of the problem. So let's solve problem number 3. The system is given as this figure. So 5 parallel forces as well as 3 the moment of couple are acting on this object. Now our objective is to replace the force system by a single force. Okay, so this problem is slightly different than what I solved. So in previous cases we had only parallel forces. Now we had the parallel forces as well as the couple of moments acting on this object. But if we want to transform or we want to replace the force system to a single force, then we can use the Varignon theorem for this one. So now first, because I want to replace the force system to a single force, it means I should know the resultant force as well as the position of the resultant force from a given point. So now first find R. Okay, what is the resultant of the parallel forces acting on this object? Okay, resultant of forces, because the red one are the moments of couple, not the forces. So resultant is again nothing but the algebraic sum of all the forces, all the parallel forces acting on this object. In this case we will use this as a positive direction and this one is the negative direction as a sign convention. So now first find the value of R. So minus 50 Newton is acting in downward direction, 40 minus 40 plus 30 plus 20 and minus 40. Okay, so this is minus 40 minus, so you will, the value is minus 80 Newton. Okay, so minus means the magnitude is 80 Newton and the direction is downward. Okay, so this is the value of the resultant force of the parallel forces. Now what is the sum of the magnitude, sum of the moments of all these, sum of the moments we can say. So now what is the sum of moments about point A? Okay, so now I will do the algebraic sum of all the moments about point A. So now we will find, this is the already the moment of the couple and we will use only the sign value is given. Okay, and we will also estimate the moments of all these parallel forces about point A. Okay, so total we will get the 5 moments from the 5 forces and these 3 moments from the couple. So we have now we have the 8 the moments about point A. Okay, so let's do algebraic sum of these moments one by one. So this moment moments of 50 newtons about point A is 0. Okay, so I'm writing the sum about point A, 0 into 50, and then the moment, this is in clockwise direction, so minus, the value is 85, okay, and then the moments of this force, and this force has tendency to rotate the body about A in this direction. This force has tendency to rotate body about point A in this direction. This force has tendency to rotate body in this direction, and this force has tendency to rotate the body in clockwise direction. Okay, so the 40 newton, the moments of this force is in clockwise direction, so 40 into 1. Okay, so minus 40 into 1, and then moments of this force, distance from point A is the 2 meter, and this is the anti-clockwise, so positive 30 plus 30 into 2, and 20 newton, 3 meter, distance from point A, and direction is anti-clockwise, so plus 20 into 3, and this force, the perpendicular distance from point A to force 40 newton is 4 meter, and direction of this moment is clockwise. Okay, so minus 40 into 4 meter is distance, and this moment m2 in anti-clockwise, m3 in clockwise. Okay, so 65 is anti-clockwise, plus 65 and minus 90. So we have 8 the moments, 1 2 3 4 5 6 7 and 8. Okay, so sum of all these moments about point A is 190 Newton meter, or we can say 190, and negative means the direction is in in clockwise. Okay, so this is the value of MA. Now so if now let's say this is the case now. Okay, so point A, and then the resultant of magnitude 80, so this negative side, so let's say this is the 80 Newton, and the distance of this resultant from point A is distance D. Okay, so we can write the moments. Okay, so moment of this resultant, so Mr is 80, magnitude of this moment is and D. So now we can use the Varignon theorem here, the 3 steps. Okay, so now we apply. To find value of D. So as per Varignon theorem, this Mr is equal to Ma. So now we know the value of Mr is 80 into D, and then Ma is, the magnitude of Ma is 190. So D will be 190 divided by 80, or D is 2.3 meters approximately. Okay, so this is our system. Point A, here is point B, and now from point, so this is the around 2.37 is here. Okay, so this is the value of the force, 80 Newton. Okay, so let's say this is the 80 Newton. The distance, okay, or we can write here. Okay, so the distance from A to this force is 2.37 meter. So this is the answer and what we want. So we can okay, so we can apply the Varignon theorem to replace all the forces as well as the moments to a single force which is acting at a given distance from a given point. Okay, so this is the answer of this problem.